Okay, so for our first example here, we have problem number 1. When x is equal to 10 feet, the crate has a speed of 20 feet per second, which is increasing at 6 feet per second squared. Now determine the direction of the crate's velocity and the magnitude of the crate's acceleration at this instant. So first, isulat muna natin yung given ng problem. We are given the speed, which is the magnitude of our velocity, which is equal to 20 feet per second. And this is increasing daw at a rate of 6 feet per second squared. Now, recall na yung velocity natin, it is always tangent to the path. Kaya minsan yung tawag nga sa kanya is tangential velocity. Now, the increase in this tangential velocity is what we call the tangential acceleration. So, rate of change ng tangential velocity. Kaya, tangential acceleration yung tawag sa kanya. Now, the problem requires us to determine the direction of our velocity and then yung magnitude ng acceleration natin at this instant. So first, let us determine the direction of our velocity. At this point or at this instant, again, yung velocity that is always tangent to the path. So, yung direction niya is papunta dito. Now, to indicate the direction of our velocity, let's take an angle. So, with respect to the horizontal, let's say this is angle beta. Now, the direction of our velocity is actually equal to the slope of the path or of the curve at that instant. So, yung gagawin lang natin is we will simply take the slope of the curve at this point. So, that is equal to dy over dx. So, yung equation ng path natin that is given, so 1 over 24x squared. So, if we take the derivative of y with respect to x, that will be simply equal to 1 over 12 times x. Now, yung point of concern lang natin is yung point where our x-coordinate is equal to 10 feet. Therefore, in order to get the slope at that point, isa-substitute lang natin yung 10 dito sa x. So, we now have the slope equal to 10 over 12. Recall that our slope, that will be equal to tangent of beta. So, in order to obtain the value of our angle beta, we will simply take the arctangent of 10 over 12. So, now we have the value of our angle beta. So, that is equal to 39.81 degrees. And then, we also need to indicate the direction of this angle. Now, next is we are going to determine the magnitude of our acceleration. So, the magnitude of our acceleration, that will be equal to the square root of an squared plus at squared. So, from our given, alam na natin kung ano yung value ng at or yung tangential component ng acceleration natin. Therefore, in order to obtain the magnitude of the acceleration, kailangan muna natin kunin yung value ng normal component ng acceleration. The normal component of our acceleration is equal to v squared over rho. So again, yung v dito is yung tangential velocity natin, and then yung rho is the radius of curvature of our path. So from the formula of the radius of curvature, kailangan natin yung first derivative dy over dx natin, and then yung second derivative d squared y over dx squared. From the equation of our path, the first derivative with respect to x, that will be equal to x over 12. And then again, at the point that we are concerned, yung x natin is equal to 10. Therefore, yung dy over dx na ilalagay natin dito will be equal to 10 over 12. And then, for the second derivative of y with respect to x, so that will be equal to 1 over 12. Now, plugging in these values dun sa formula ng radius of curvature natin, we will have the value of our radius of curvature equal to 26.468 feet. Yung normal component ng acceleration natin ngayon will be equal to v squared, again, that is equal to 20 feet per second, divided by the radius of curvature. So this will be equal to 15.11 feet per second squared. So now we have the two values of the components of our acceleration. Therefore, makukuha na natin yung magnitude niya. So, square root of 15.11 squared plus 6 squared. We now have the value for the magnitude of acceleration equal to 16.3 feet per second squared. Okay, so ganun lang, no? Madali lang siya. Kailangan lang nating i-analyze ng maayos yung problem para ma-apply natin correctly yung mga formulas natin. So for our next example here, the train passes point A with a speed of 30 meters per second and begins to decrease its speed at a constant rate of negative 0.25 meter per second squared. Now determine the magnitude of the acceleration of the train when it reaches point B, where SAB is equal to 412 meters. Take note, itong SAB na to, that is the distance traveled by the train from point A to point B. So that is along the path. Okay? So sulat lang natin yung given dito. So again, itong velocity natin, that is always tangent to the path. Therefore, the rate of increase or decrease of our velocity will be equal to the tangential acceleration. So yung hinahanap sa problem is yung magnitude ulit ng acceleration at point B. And in order to obtain this magnitude, we first need to determine the values of the components of our acceleration. Meron ng given na tangential acceleration. Therefore, yung normal component naman ng acceleration yung kailangan nating hanapin. The formula ulit for our normal acceleration, that is equal to v squared over rho. Since we need to determine the magnitude of our acceleration at point B, yung gagamitin natin na velocity dito will also be the velocity of our particle, or in this case, our train at point B. And then yung radius of curvature din natin will be the radius of curvature at point B. Again, dapat consistent sa mga values na ilalagay. So first, we need to determine the velocity at point B. Kasi yung binigay sa problem is the velocity at point A. Okay? So, hindi natin pwedeng i-substitute yung 30 meters per second dito. So, in order to determine the velocity at point B, we will use this relationship, ADS equal to VTV. Yung acceleration natin will be equal to negative 0.25, and then we will simply integrate both sides of our equation here. So, at S equal to 0, or at the initial position, yung velocity natin is equal to 30 meters per second. And then at S equal to 412 meters, yung velocity naman natin will be equal to velocity at point B. So after simplifying this equation, we now have the velocity at point B, and that is equal to 26.3439 meters per second. Next naman is we need to determine the radius of curvature at point B. So using the formula for our radius of curvature, and then galing dun sa equation ng path natin, kukunin natin yung first derivative of y with respect to x, and then yung second derivative of y with respect to x. And then again, at point B, yung value ng x natin is equal to 400 meters. So we will just substitute 400 dito sa x. And then now we have these values. Ilalagay lang natin dito sa formula natin for our radius of curvature. Now we have the value for our radius of curvature at point B, which is equal to 3,808.9649 meters. So ngayon, meron na tayong velocity at point B and then radius of curvature at point B. Therefore, makukuha na natin yung normal component ng acceleration natin at point B. So this will be equal to 0.1822 meters per second squared. So ngayon, kompleto na yung components ng acceleration natin at point B. Therefore, we can obtain the magnitude of our acceleration at point B. So this is now equal to 0.309 meters per second squared. Okay, so that's it. Again, I suggest that you practice solving these types of problems. Solve lang ng maraming problems para masanay kayo sa method na ginagamit natin. That's it for this video. So sana meron kayong natutunang bago. Okay, see you on the next one. Peace!